Hey guys, Joe up here, and welcome to the third video in our 2E platformer series. And today we're going to be adding in the actual movement, the proper movement of the player. We're going to actually do all of it. It might be a little bit of a long video, but it'll be good. Now, I forgot something that we're going to need for our player here, and that is I want access to this game manager for all my game objects, because the game manager is also going to have our level information. And a player needs to know that information in order to function. It needs to know when it's hitting something or when it's not. So we need to give player that information. So I'm going to change my game object here and update to also take in a game manager, and I'm going to call it GM. So it's good now that because we only have one class to change, but we're going to do that. So now my game manager is in my player. So I'm going to go back to Game Manager though, because I need some methods for getting our collision information. So I'm going to add in some like getters here. So public, not void, int, get, yeah, we'll call it get collision. Get collision. X plus 1 times level image document. Wait, what am I doing? Collision. Now, I think I'm actually going to change something up here, because our collision really is just 1 and 0. We're not going to have anything more complicated than that. So, like, we could do, it slows you down. But we're not really going to do that. I'm actually going to change collision to be a boolean. And we'll have other tiles for other things. So, actually, this will be true. So, if this, draw that. Else. So this makes it just a little bit simpler. So instead of setting it to 1, we'll set it to true and set it to false, which is 0, which is actually what true and false are defined as. True is 1 and false is 0. It's the same thing. So you might as well do that, and it'll save us an extra step when we make our if statements. So we're going to get collision, and I'm going to get it at int x and int y. And simply, I'm going to return my collision at x plus y times level width, right? But here's a problem. What if we try to get something that's a collision that's not in our array? We're out of bounds. So we need to make sure that our x and y are in bounds, or else we could have problems. So if x is less than 0 or x is greater than level width, this should be greater than or equal to. And we'll do the same thing for y. Then I'm just going to return true. Right? So if we go outside of our level, everything outside of the level is solid. So it'll just be true. Alright? So update, so we gotta change update to pass in this, which is our game manager class. So we're gonna throw our game manager into our object. Gotta update that. And so now everything is nice and set up. So let's actually set this up. I'm going to actually move my player real quick because he's in the wall, and I'm going to actually add in gravity. That'll be our first thing. We're actually going to do gravity. I said it would be the next thing, but I'm going to do it now. I think 4-4 is an empty spot. Yes. So this is a good place because we can fall down and we can land on the block. So let's go to player, and I'm going to get rid of like all this. So in order to fall, I need to know this is how I do it. So I have a private float, and I'm going to call it fall distance, which is also going to be our speed, okay? And so our fall distance, I'm going to always subtract equal dt, and I have speed here, but I need a private float fall speed. I'm going to set that to 10. This usually doesn't need to be very big. Let's do fall speed. So how fast are we falling? Okay. So, and then at the end here, I'm going to say position y plus equal fall distance. All right. Oh, wrong way around here. Let's add that on there. Just add it. Okay, so we fall down, and you see how we fall down? Nice gravity motion, which is, this is the proper equation for falling. You just keep adding on to the fall distance, a number, and then you add the fall distance to the position, and that's how you get a quadratic movement. You know, like a parabola. It follows a parabola acceleration, which is what you want. I know, but here's the problem. We're falling, but we're not stopping. So I'm going to do a simple thing here where I'm going to have position. Now, here's what we need to do actually before we continue. We have our position X and our position Y, right? Which is going to be our final like screen position, but I need to know I need two more variables to know my position. And that'll be a private int tile X and a tile Y. I need to know what tile we're in, and a private float offset X and an offset Y. And that will be the actual like how far to the left and right, up and down on the tile that we are. And those combined will give us our position. So I'm going to actually just type that in right now. So our position X will be equal to our tile X times 16. And I'm actually going to change this real quick, because I'm going to go to game manager here. Before we type 16 way too many times, I'm going to make a public static final int TS for our tile size, and I'm going to set it equal to 16, so that if I want to change it, I can. And now I'm going to actually just Control Shift F. I'm going to find 16 and replace it with TS. Replace all. Boom. And I'm going to do the same thing in player. 16 with TS, which we don't have any. We only have one spot for it. Tile size. Okay. Can't do just directly tile size. I have to do 16 and then game manager.ts. Replace all. And there we go. Plus offset X. Alright, and the same thing here for position Y. And this is how we're going to do our calculations. So, we have our fall distance, and we're going to add on to our fall distance. Alright, and I'm going to do a simple test here. So let's say gm dot hit collision at tile X, tile Y, and I want to check the tile below us, so that's going to be tile +1. We actually need to initialize our tile X, which is up in our constructor. Our tile X is going to be position X, and our tile Y is going to be position Y. Okay, and I might as well also set our offset X is equal to 0, and this dot offset Y is equal to 0. So we have them both equal to 0. Okay, so if the bottom is solid, I'm going to say fall distance equals 0. Otherwise, we're going to do position. We're going to do offset Y plus equals fall distance. Otherwise, we're going to fall. So what's going to happen here? Error. Where did I put something's wrong over here? Oh. You can't assign a variable to itself. When I replaced all the 16s, it did that. And anything else? Why is it just saying that? It's just saying that to say that. So we fell, but we didn't stop, because we haven't moved our location. So when we move, before we actually set it, we need to check to see if our offset X has gone far enough to say that we're on a new tile. So if we're on, I'll draw a little image here to make it a little bit easier to understand. 640 by 480. So image, your grid. We'll throw up a little grid here real quick. View, show grid. So here's our grid of collisions, and I'm going to make a little player. Let's see here, grab a shape. Select right here, fill it in. So here's our player, right? So we are currently in this tile, right? And I want it to be that we are always in this tile, but when we go over the halfway mark into the next tile over, our tile position will now say we are in this tile. All right, same thing this way. When we go over the halfway mark, we're now in this tile. Same thing up and down. So as long as the center of our tile is in that tile, we are in that tile. But when we cross over the halfway mark, we move tiles. And that works the same way. So if we're in this tile, we're going to check the location below us, and as we move over, we have to check the tile below here. If we're in between, i.e. we're not perfectly in one tile or another tile, we have to check the 2 tiles below us to make sure that they're solid. Okay? So let's implement that. So right now we're perfectly in the center. We can't move left and right yet. So I'm going to check to see if the bottom tile, so we're going to check if our offset y is greater than TS divided by 2. So have we gone halfway over? Right? Also, this isn't TS, this is game manager.ts. If it's over 2, then our tile y, we advance by 1, right? And we set our offset y to equal, actually we're going to subtract our game manager.ts from it. So that will effectively move it over with the decimal places. Because if we just like set it equal to half of this, we could be off because we're using a float. Now if I run this, we stopped. All right. Let's move the player over just a little bit just to show you what happened here. X6, that should be over enough. He falls and we stop. So now our tiles move down and we detected this tile and we're halfway across. So it says we're here and we see the tile below us is solid, so we stopped moving, right? But we want the player to come all the way down here before stopping, right? So how can we do that? I'm going to add in another thing here. So if offset y is greater than TS, we have that, that's fine. And here we have our collision, but I also want to check and our offset y is greater than or equal to 0, right? So that means that we'll be fully on the tile below us. So that way we're touching the ground when we stop. So if we do that, ooh, we overshot it a little bit, which can happen because our thing's going too fast. So we need to set our offset y back to 0. So we land on the ground and you get boom, and now he's on the ground. Simple, right? Now here's the problem. So our fall distance can be further than the ground, and then the next frame it checks to make sure, hey, are we on the ground? And so if you notice, he dips below and then pops back up real quick, which is can be solved simply by moving this plus up here. So if we do that, it should check and he should land solid. He doesn't bounce. He was doing a little bounce. Now he just lands nice and solid, right? So now we have him falling on the ground. Let's add in the jump, because the jump is actually very simple. So here we'll add in the fall distance, but if we say if gc.get input that is key, and I'm going to do down, key event.dk equal to w, then I'm going to say fall distance is equal to, and this is going to be jump, which is going to be a new float up here. So I'm going to say private float jump. I'm going to set that equal to 10 or something. Negative. It needs to be a negative number because we want to move upwards. 10 might be too much. 2, it's usually a small number for jump. So let's go for 2 and see how 2 looks. Now we might have a problem here because of this, and we probably will. So let's see if we jump. We jump. Look at that. We got a nice little jumping guy, and we can spam it because it doesn't check to see if we're on the ground when we jump. Okay? So that's perfectly understandable, but we want to make sure we're on the ground. And an easy way to do that here is this is checking to see if we are on the ground. So I'm going to come back up here once again. And I'm going to add a new private boolean ground equals false. So if we come down here, we can say right here, say ground equals true. And when we jump, we're going to say ground equals false. But our if statement will only allow us to jump if we're on the ground. Okay? So if we come back into our game, we can only jump when we're on the ground. So now we're starting to get somewhere here. Okay, and I'm going to actually comment on this code here and say this is jump and gravity. Now I'm actually going to start organizing my code a bit because this class is going to get a bit big. I'm going to say this is beginning of jump and gravity, and that's going to come down here to here, which is the end of jump and gravity. This is a way I like to organize my code. It keeps it looking nice. So you get little blocks of code like this. Okay, now this collision here, our ground collision isn't good because we're going to now add in moving left and right. This is going to be a long video. So that we're going to do left and right, end of left and right. So simply, let's just start by adding it in. So gc.getInput that is key, and I'm going to do key event.vk equals d, and we'll do the same thing for gc.getInput that is key event.vk a. Okay, and what we're going to do is offset x, we're going to add to it our dt times speed like we did before, and our offset y we're going to add offset x minus equal dt dot times speed. Right, simple. But here's the thing. So we can move now left and right, but our tile position x is not updating. So over here it thinks we're still over here and we're on this platform, so we're not falling down over here. So let's head back down, and we need to add in, we'll call this final position, and we need to do the same thing here. And I'm actually just going to do the x, y one as well. So if y is less than negative half the tile, then we're going to subtract from the tile and add. And we need to do the exact same thing, but the reverse for x. Alright, so we just need to change it all to x. So x, 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 and x. Now that should properly move our tiles. Alright, so now we move left and right, and we fall down because we went down a thing. We can't really even jump up a block, so we should probably make our jump a bit taller than 2. About 3? What does 3 give us? 3 gives us a nice jump. And we can jump up on the platforms here. How about 4? Let's do 4. 4 will probably feel good, but it might be a little bit. No, it's good for right now. So we're testing out our platforming here. So we can walk through walls, but we are colliding with them on the ground. But we can kind of just jump up through them. But here you can see, when we walk off to the edge, when we move over a tile, we fall through the floor, which we don't want, and we'll have to fix here in a second. But we got some decent platforming going on here. Okay. So we have left and right going, but we don't have any collision detection for our left and right. So what we need to do is we need to test if we can do this. So what we need to do here, there's a lot of ways we can do this. And let's see if I get the correct way off the bat, or we have to modify it. So I want to move left. So if gm.get collision at tile x plus 1 and tile y, if there is a collision here, I still want to add, right? So what I'm going to do here is there's a solid tile there, right? But we have the same problem as when we go down, is we want to make sure we're over. So if we're here, I want to say if, and then we'll have another if statement in here, which will be if offset x is less than 0, because we're adding, so we need to be less than. We want to be negative is less than or equal to 0, I guess. We shouldn't say equal to 0, because then we can just repeatedly spam walk into the wall and it'll look really weird. So I want to do that if that. But I left this if statement separate because I want to put an else here. Else, if there's nothing to our right, just keep walking like normal, right? So if I come back in, I can walk to the right, but if I walk over here, hey, look at that. It stops me from walking into the wall. And now we do the same thing over here for left. So if gm.get collision tile x minus 1 tile y, right, and we'll do the same code. If offset x is greater than 0, because we're going the opposite direction here, else just move as normal. Okay. So now we have both left and right. So if I go left and I go right, we collide. But here's the thing. We don't actually set our position to 0 when we collide. So I can stick my head into this block here. So if we do collide here, else offset x equals 0. Same thing down here, else offset x equals 0. So if we do walk into the wall, I want to make sure our head isn't sticking through. I just clipped for like a second there. I can still clip. And the reason I can still clip is if I'm not holding left, it clips in a little bit. A little weird. And it may be because of... Because for one frame, we go into the wall, and then we come back around, and it checks our collision, and it goes, oh, we're colliding, set it to 0. So we can stick our head still into the wall for one frame, which is not good. So we can fix this. Alright, so we need to make sure that after we move, we check again. Are we over 0? Right? So I'm going to do another test in here. And we might actually be able just to get rid of this offset x. Actually, no. So we got to check it again. So if we are greater than 0, again, after doing this movement, I want offset x equals 0. Right? So by adding this if statement to both of these, we should get the proper result. And less than. 1 second. Sorry about that. So now that we test it again, when we come back through here, we shouldn't get going into the wall. Up. We get kind of thrown into the wall, it looks like. Feels like we're magnetic now. Because we skip a frame. That's what's happening there. So when we add it in, seems like it adds it. It seems like it just skips a frame. Like we move twice as fast for some reason, and it just pulls us into the wall rather than see. It kind of looks like it's snapped in place. Oh no, there's a little spot where you can't get out. That's weird. Do I have those reversed or something? I think I have those reversed. Yeah, I have those reversed. That's why. They have to be a stand. There we go. Now we're not getting pulled in, and we don't stick our head through the wall. We still have the problem of moving downwards. We fall through the platform, and we don't have any collision upwards. But we're getting there. We're getting there. We almost have our player moving around here. Okay, so let's fix falling downwards here, because we got a problem. Okay, because that's an easy fix. So we have our jump position and we're checking the ground here, right? We're going +1, right? Well, guess what? We need to do even something more. So we need to check x +1 and x -1 depending on offset x and y. So basically, we need to add on the offset x signum. Now I don't actually know. I think 0 is 0, right? Hang on 1 second. I'm going to look up Java math, because this might all be able to be done in one if statement. So I'm looking at the math here, and I'm looking at the sigma function, which returns whether something is positive or negative. Does it return 0 if 0? It returns the sigma function of the argument 0 if the argument is 0. So yes. So basically, we can come into here and we can say math.sigma of offset x, right? So if we're a positive offset, right, we're going to check that, and if we're negative offset, we're going to check this. So we also need to add in another if statement here as well, because we need to check two positions at once. We can't just check one. Also, for some reason, this is a double, which just needs to be an int for some reason. But I'm going to add in this, and we still need our original tile x and the sigma. So now, if we are slightly off, this should not be and, this should be or. Right, and it might be inverted. So if I come over here, see, look, I can come over all the way to the edge and then I fall off. Oh no, I can't get up. Why can't I jump now? We want to make sure these are together. I'm going to put these in parentheses to make sure that it's oring these two together. Just to be sure. There we go. Now we can jump. So now if we come to the edge, we can ride our square all the way off and then fall down. Same thing over here to the left, where we can ride it all the way down. So we can even move across this one wide gap because our square, it's really hard to get the square to be exactly in the middle and fall down, which can be a problem. So what I can also do here, I can also, so this is going to get the sigma, plus or minus offset y. We'll add in a little bit of boundaries, because you don't want your player to be the exact same size as the hole, because as you can see over here, it's really hard to get the player to fall down this hole. And well, actually, this we can probably fix it by setting this to an int of offset x. Because if it's -1, it will be How can I get this? Because if I set it to an integer, it'll just set 0 and it's 0. If it's less than 1, which it will be. Yeah, it's fine. Actually, that should be fine. I might be overthinking it just a little bit. So if I come over here, I can now fall in easier, and I still hold on to the edges, but I can actually fall in now because it does test to see if it's 1. So we can fall into our hole now and get stuck. So now we need to actually test if going upwards for collision, right? Because we just jump up through things, which is not the intended function here. So let's add, so this is if our offset x is greater than y, but I want to do this if our fall distance is greater than 0. Right, so that means we're falling downwards, right? We're going to test this downward collision only if we're falling downwards. Otherwise, there's no reason to test it. But if we're falling upwards, aka fall distance is less than 0, then we're going upwards. And I want to check if we're colliding with the ceiling. And I don't want that to loop around. So I'm going to copy this. And we're going to get rid of the ground, because ceiling ain't ground. And then we got to change it to y minus 1. Y minus 1, and change it is less than 0. And actually, I'm going to change that from greater than to equal to as well. Okay, and that should, in theory, work. So if I jump, I hit the ceiling. I now hit the ceiling no matter how I jump. So if I come down here, I can't jump up, and I can jump into the little hole here. Okay, so look at that. Now we're talking. I hit the ceiling. Just like that. Pretty cool. But we still have a problem. At least I see it as a problem. Is we can, you see, if I can get it to go right, we can clip the corner. Come on, clip it. But you can see our square overlaps the black just for a second there. Like 1 frame. It might be really hard to see on YouTube, or it might be easy to see. But you can see like the corner clips for like a second. And that is caused because when we're checking collision to the right, We're going to the right. We're only checking the block directly to our right, right? So we're right here, and we're midway between here, and we're considered on here. We're checking collision here. We're not checking collision up here. We're only checking it right here. So if there's no block here, but there's a block here, we can still move, right? But we don't want to because there's a block here. So we needed to do the same thing we did for falling down, but for going left and right as well, right? So I'm going to do the same thing. I'm going to copy this. I'm going to paste it with an OR. And we're going to do the same thing for y. So we're going to add plus the integer of math.sigma of offset y. And also, once again, I'm going to cast the offset y itself to an integer. And I'm going to copy this over here and make this plus. And that should solve our problem as well. So now I come down here and let's see if I can get the corner to clip. I cannot get the corner to clip because it now properly checks that I am fully in the block before allowing me to go over. Alright, so now I have full collision. I should not be able to put my cube anyway into these black parts at all because my player movement now completely collides with everything. Right? And that works very well. And we did it in not too bad of a length of code, if I do say so myself. So, that's going to do it for this episode. We got the player movement down. So, that's it. Next episode, let's add in, I don't know. I don't even know what we're really making. We're just making a 2D platformer. So, it's not really like we're making Mario or anything. We're gonna make, let's add shooting right now. Let's add in an object where we shoot and then the bullet itself collides. It'll do in a similar manner, but the thing is that the bullet isn't 16 by 16. It'll be like 4 by 4. So our collision method will have to, we're gonna use the same kind of technique for colliding with the terrain, but it needs to take into account that it's 4 by 4 and not 16 by 16. Okay? Which is not as hard as you think it would be. It's just a little bit of modification. So yeah, that'll be the next episode. So guys, comment, rate, subscribe, and thanks for watching.